Hi students, welcome on the channel. So in this video I'm going to talk about this JEE Advanced question, JEE Advanced 2020 question, where they have given that there is a meter scale. So basically the length is, this total length is 100 centimeter or 1 meter. Horizontally is scale horizontally on your extended index finger with the left one. So we are putting this scale onto the our index fingers. So this is index finger first one, and this is our second index finger. This is left one. Okay, this is our left index finger and this is our right index finger. So yeah, when you so right one is at 90 centimeter, okay, and left one initially is 0 centimeter. When you attempt to move both the fingers slowly towards the center, slowly means almost like with zero velocity, initially only the left finger slips with respect to the scale and the right finger does not. So maybe because of some situation at t equals to 0, when we are initially in this step 1 we are trying to slide, then the left is sliding. Okay, so when the left is sliding, so then it will move in that direction, but r is going to stay there itself. Okay, and because of that the total scale is going to be there itself. Okay, then they are saying that okay, with respect to scale and the right finger does not slide, after some distance the left finger stops and the right one starts sliding. Then the right finger stops at a distance xr and the center from the xr from the center 50 centimeter of the scale, and the left one starts slipping again. This happens because of the difference in the frictional forces. If the coefficient of friction, kinetic friction and the static, so static is this one and the kinetic is this one, so what is the value of xr? So see, they have given that this is our first attempt when we are this is our first stage when we are just trying to slide. So then the left is sliding. Okay, so let me just draw the scenario again. So this is initially, then at some point this is we are sliding, so this will start to slide at some place and it will stop at some place. Sorry. Okay, let me call these normals like this. Right now this normal is nl1 and this is nr1. Okay, in this scenario, and here it becomes, let's suppose nl2, normal will also change, will come to that nr2. Okay, at some distance it stops. Okay, let's suppose it is stopping at some distance, you can take it maybe x1 or something. Okay, and then we start to slide the right one. Okay, so then the right one starts to slide, so let's just copy it, and here it is. See, this is a JEE advanced question, so you need to have a time to think. Okay, so that's why let's just draw the scenarios what we have here. At some point it is stopping again, and they have said that this distance is something xr that we need to find out. This is the xr we need to find out. Okay, so these are like three diagrams which will help us to find out. This is the complete scenario in this question. First, nl1 and nr1, they are balancing, and the right one is not at exactly 100 centimeter, it is at 90 centimeter. This is at meter scale, and then because of the difference in the normal, because of the difference in the normal, there will be difference in the friction and maximum limiting frictions, and because of that maybe at left we have lesser friction, so that's why the left will start to slide. Okay, at some point the friction in the left will become more than the right. Which one? The kinetic friction. See, it is sliding right now. Right now it is having, all the way it is experiencing kinetic friction, and all the time it is experiencing static. So if the kinetic of this one at some point becomes equals to this one, so then it will start to slide. As soon as it will start to slide, the kinetic, it will turn into the kinetic, which will become lesser than the this one, and this will become static, so it will rise. So again, because now we are sliding this one, so normal will keep on increasing. Normal will increase because we are moving towards the center, so this normal will increase. At some point, the kinetic of this one in this scenario will become static of this one, and then afterwards this will start to slide. So this is the complete scenario. So let's first find out nl1 and nr1. See, nl1 and nr1, directly you will not say that they will become w by 2 if the w is the weight. Okay, let's take that w is the weight. So then they will not become w by 2 because here nl1 and nr1, they are not acting same distance away from the center of gravity or center of mass. They are acting at different distances. So that's why one equation which you can form from the this translational equilibrium is in the y direction. We have translational equilibrium, so that's why you can say nl1 plus nr1 is equals to w. Okay, this is our one equation. Although this equation will be true always, like here also in this scenario, nl1 and nl2 and nr2, they are balancing the w, and here also they are balancing the w, isn't it? So always that is true. Okay, this is true always. Fine. And now comes the rotational equilibrium. See, the problem is these two forces are acting at different distance, and this rod is also, or this scale is also in the rotational equilibrium. It is not rotating about any axis, so that's why it should have torque to be 0 about any axis. So let's take this as the axis of rotation, and let's find out the torque about this point. If I calculate the torque about this point, this will apply a clockwise torque and this will apply a anti-clockwise torque. Okay, and this distance is going to be 50 centimeter because from the center it is at 0 0. Okay, the reading are 0 0, and center of gravity, of course, it will be 50 centimeter. It will be always at 50 centimeter whether we apply the normal anywhere. And this is 90 centimeter, 90.00 they have given in the question, and this is 100. Okay, fine, because it is meter scale, I am taking in the centimeters. So this, does it become 40? Yes. So I am saying torque is nl1 is applying a clockwise torque. I am taking the clockwise to be positive, so nl1 times of 50. See, I am putting in the centimeter, both the places will put in the centimeter, and torque we will equate to it to 0, so that unit is not going to matter here. So that's why minus of nr1 times of 40, this becomes equals to 0. Okay, so 5 times of nl1 is equals to 4 times of nr1. All right, yeah, this question was asked by one of the student. It is quite interesting question, so that's why I thought of sharing with all of you. So here we have nl1 is equals to 4 divided by 5 times of nr1. Okay, let's find out the values from here. So if I substitute over here in the equation 1, this is our equation 2. If we substitute in the equation 1, so then we'll have 4 by 5 nr1 plus nr1 is equals to w. So then this becomes 9 by 5 times of nr1 is equals to w. So here in this scenario we have nr1 is equals to 9 by 5 w, and from there if we calculate the nl1, so then it will become 9 by 5 times of 4 by 5. Sorry, does it become 5 by 9? Okay, that's my mistake here, 5 by 9. And if we multiply by 4 by 5, so then it will become 4 by 9 w. Okay, so these are the normals. Now if we calculate, see, if we calculate the friction here, the kinetic friction at the place 1 will be mu times of n L1, and static friction at the place 1 will be mu times of n L1. The same way if we calculate kinetic and the static at the place 2, so then mu kinetic and mu static, this will be mu kinetic times of nr2, and this will be mu static times of nr2. Now see, nr2, is it greater nr1, sorry, nr1, is it greater than nl1 or not? Yes. If it is greater and both the fingers are at rest right now, so this static friction will act first, right? Okay, this is our static friction. So this static friction will act. Now this static is more than this static. So when you try to slide, where do we have first sliding? At this place, isn't it? Because this static is lesser. So at some point, like if this friction is acting like this, F on the scale, it is acting like Fs1. On the finger, it is acting like Fs1 this side, and this will be Fs2 this side, and on the scale, and this will be Fs2 on the finger. And see, because scale is not moving, so that's why whatever the friction will act at this side, the same friction should also be there the other side. Now what happens, if we gradually try to move, this value will increase and this value will increase. At some point this value will become maximum, but this will not become maximum. Then what will happen, it will start to slide, then this friction will turn into the kinetic. Hope you understand this, what I am explaining. Why, the question is why this first finger or the left finger will slide, not the right. So just to understand this one, of course, like by the intuition we can say, okay sir, this is going to slide because the normal here is lesser, but mathematically also we need to understand this, that what happens, that we gradually try to slide that, so we are increasing the whatever the force of application is on there on the fingers, and because of that the whatever the opposing force friction is there, that will also increase. Okay, and the friction will keep on increasing both places, it will increase, because both places the friction will be same. Why? Because this rod is not moving horizontally, and some point this will not be able to resist, then it will become turn into the kinetic, and the fingers will start to move. Left index finger will start to move. Okay, if you understood this, then you can also understand when they will stop, because you are taking this side, gradually this normal will increase. Okay, if you if you do not believe this, so then you can just have a mathematical relation here. See what will happen, every time the torque about this will be 0 or not, about the center of gravity. Yes, it will be 0. So at some point, let's suppose the distance of NL2 is, or normal from the left side is x. Okay, so then you will say normal from the left side times of x is equals to normal from the right side, and let's suppose this is y. Right now y, is it fixed or not when we are moving from this event 1 to event 2? Yes, y is fixed. What is happening to the x value? X value, we are moving towards right, isn't it? So this is a good question. Try to, like, it may become a bit lengthy, but try to be there in this complete lecture so that you understand. Okay, or try by yourself this question and then come with your solution and try to look at this solution. So when you are going through this solution, you need to be a bit patient to get to the answer. Okay, so what is happening, x is, what we are doing is x, we are gradually decreasing. Okay, so nl1, this is something constant. Okay, we can say, then what is happening, x is decreasing, so nl1 must increase, it will increase. Okay, hope you understood. So if nl1 is increasing, the friction which is acting on the finger and this scale will also increase, and this will lead also to increase this one. At some point, the kinetic may become equal to the static of this one, which was acting here. Okay, at some distance. That place, this will immediately turn into the kinetic. As soon as it will turn into the kinetic, it will drop, and because of that, this finger will start to move. Okay, so let's find out first what is this x value. So x value, let's first find out, okay, let's form the equations first. Okay, so one equation is this one. Let me form from here only. And L2 times of x1 is equals to whatever that value is there. What is that? nr2 times of 50. Okay, 40. Now nr2 value, okay, nr2 times of 40. Of course, nr2 will also change. nr2 is not going to be same. And second we have is this equation, nl2 plus nr2 is equals to w. Okay, right. And the one more equation we have, that the kinetic of this one becomes equals to static of this one. So kinetic of this one will be mu kinetic times of nl2 becomes mu static of nr2. Okay, fine. Okay, so from here mu k we know that is given in the question. It is 0.32 and mu s is 0.4. So 0.32 times of nl2 is equals to mu s, which is 0.4 times of nr2. So 32 times of nl2 is equals to 40 times of nr2. So it becomes 8 by 8 we can divide. So then 4 times of nl2 is equals to 5 times of nr2. So from here we get nl2 is equals to 5 by 4 nr2. Okay, let's place it in this equation. So if you place that into this equation, so then we'll have the values as well. Okay, let's avoid this calculation. I just don't want to calculate this, because I just want to proceed with x value. Okay, so let's find out the x value from here. So I have nl2 nr2. Okay, so nl2 I can write it as 5 by 4 times of nr2 times of x1 is equals to nr2 times of 40. So from here I will have x1 is equals to 40 times of 4 divided by 5, which becomes 32 centimeter. Okay, so what happens right now, this x1 is 32, x1, this one is 32 centimeter. Okay, so x1 we got. Now we'll proceed on to the xr. So see, from here if we are going to this one, the same phenomena will happen. This right now is kinetic. At some point the kinetic of this one will become static of this one, right? Okay, so kinetic of this one becomes equals to static of that one. So kinetic is 0.32 times of nr3 becomes 0.40 times of nl3. So from here you will have the same equation, same kind of equation, nr3, 4 times of nr3 is equals to 5 times of nl3. Okay, so from here you get nr3 is equals to 5 by 4 times of nl3. Okay, one equation is this one. Another equation is torque balancing equation about this center of gravity. So then you will say that nl3 times of x1 is equals to xr times of nr3. Okay, just place the values from here. So we got nl3 as nl3 only. x1 we got is 32 centimeter is equals to xr that we need to find out in this question, and nr3 is 5 by 4 times of and L3. So this will be cancelled out. So XR becomes 32 times of 4 by 5. So this is 8, 128 divided by 5. So XR value from here becomes 25.60 centimeter. So this is the answer in this question. So I hope you must have understood this calculations. Like once you proceed from event 1 to event 2, so then 2 to 3 is quite easy. That same kind of thing is going to be there. So this first should stuck in your mind that okay, I am going to proceed this question. So whenever there is a JEE Advanced question, I will say that some strategies that you can develop from your 11th onwards only, if you are a 11th student, and if you are a 12th student, so you have quite a bit of experience of handling the questions. So I will say that you can, whenever you have a JEE Advanced question, you have a time to think. Okay, there is a difference in the pattern of the JEE mains and the JEE Advanced examination, where in the JEE mains we have around 2 point some seconds, some minutes, 2 point some minutes, or I will say 2 minutes to solve one question. But instead of that, in the JEE Advanced question, let's suppose you get something 18 question something or 20 question is something, so you have almost 3 minutes, okay, solving one question, or sometime more than 3 minutes, 4 minutes, 5 minutes, like this you will have. So and in that also, out of 18 you are not going to solve 18. If you do even 10 questions some things, that is also perfectly fine. So 10 question means you are going to spend maybe 6 to 7 minutes on a question, on an average. Some questions may be easy, that may be done maybe 3 minutes or lesser than that. So in these kind of questions, like when you get and you see that you know the concept and you can proceed with this question, so try to think the ways in which you can solve. It will not be always that the method will be a method which you have already seen. Okay, it is like hardly like that. Many times the questions which are tougher side, they will always have the new method of solving and new approach of solving, so that will require a time of thinking. So give the time. Whenever you have the advanced paper, you will have plenty of time, so you give the time to the questions and try to solve them. Okay, yeah. So I hope you must have understood some things and you have learned something from this question. If you want to watch other videos, there are available on the channel. You can share this video with your friends if you like it. Thank you very much.